Hello, everyone. My name is Mike Ranieri. I'm from Dell Technologies. I'm one of the co-chairs of the Redfish Forum, and we also have Bill. Bill, why don't you introduce yourself?
Hello, I'm Bill Scherer. I'm from Hewlett Packard Enterprise, and I'm the other co-chair.
All right. And so for today, we'll be going over the Redfish Release 2026.1 package. So this became public a couple weeks ago. Within the 2026.1 release, we added a new minor version of the Redfish specification. We're up to 1.24. Within the spec, we added new options for a push-based boot image support, so you could kind of bootstrap your computer system through a single API. We'll talk more on that later. We've also added a new type of query parameter called client context, which is used to help clients iterate through collections and see notifications of new members being added. And again, this is another subject we'll go into a bit more detail about later. Within the 2026.1 bundle, we've added a new message registry package. So DSP 8011 contains all of our existing message registry files. Some of the highlights include we've added a new version of the environmental registry, which adds dew point and coolant connector pair reversal messages. We've added a new version of LogService, which adds a new diagnostic data lifecycle messages like I started collecting data, I failed to collect data, and other types of events. Within Power, we've added new chassis power limit messaging. And in the update message registry, we've added support for conveying when images are staged and applied to devices. We've added a new minor version of the Redfish interoperability profile specification. We've added two new terms. One is called priority, which is used to convey to a possible supplier. If you fail conformance in this is kind of how we rank the priorities of our requirements in the profiles. That way, you could best figure out which areas to solve first for your particular customer. And then we also added in a new error response term to the protocol requirements section, so you can start to convey how much detail goes into error reporting in particular. How do you show your types of resolutions that you can apply to error messages? Added a new schema bundle. So DSP 8010 contains all of our existing schemas and our audit releases. Some of the highlights of that include a new resource called MemoryExtent to support some of the new CXL 3.2 dynamic capacity features. And then we also have we have 35 updated schemas, and some of the highlights include some other changes to existing schemas to support the new CXL 3.2 dynamic capacity features. So updating CXL logical device, PCI device, memory chunks, and memory region to tie into that new modeling pattern. We've updated computer system to provide that new boot image API. And we've also added a few new pieces to support personal devices like laptops and desktops. So we're starting small with adding in new power state and reset type of values to support sleep and hibernation options. Going into the CXL updates, so as indicated previously, CXL 3.2 includes some new dynamic capacity features, and so Redfish grew to incorporate those additional changes. We've added full support for all of the types of dynamic capacity add and release policies, and these just come right out of the CXL spec. There's a free, contiguous, prescriptive, tag-based, and enabled shared access. So this new change allows for memory referencing to shift content between different CXL logical devices. And so by enabling that, you can now start to express moving memory between different hosts on a CXL fabric. So this adds full support for memory sharing as well. So not only can you move memory, you can map memory to multiple hosts. We've implemented the memory tag management that's defined in the CXL spec. And we've added the new memory extent capabilities that were defined in CXL 3.2. So the main highlights again for the CXL updates, we've added a new memory extent resource to define the memory extent as put in as defined in the 3.2 spec. We've added new actions to CXL logical device, so dynamic capacity add and dynamic capacity release. Those are used to add or remove memory regions from a CXL logical device. And then we've updated memory chunks, memory region, and PCI device to tie into this new memory extent modeling. So from a pictorial perspective, at the center, we have our new memory extents collection hanging off a PCI device. The reason it's out off a PCI device is since this is a shared collection with other logical devices potentially, you can't tie it to a single logical device. This can move between different logical devices. And so that's why we put that at the PCI device level. And so now memory regions exposed by a CXL logical device, they can map back to a memory extent. And then that also maps back to your physical memory as part of memory chunks. And so this type of mapping allows you to map a memory extent to multiple memory regions for different CXL logical devices. You can move it around to migrate between hosts, or you could completely share it. And now I'm going to pass it off to Bill to talk about the new boot image API.
Okay, thanks, Mike. So yeah, so for boot image, we have a new boot image push URI property in computer system, and this creates a single unified URI for allowing clients to boot systems to that target URI using virtual media. So from the client perspective, it just uses a multi-part request to provide the binary image of that boot image. It can supply any optional parameters in JSON form. And so this is very similar to our existing HTTP multi-part updates. Now, from the service perspective, on its part, it caches the received image under this particular URI, Redfish V1 update service local image store. It then mounts that image on a virtual media slot that's accessible to the system. It triggers a system reset and automatically boots to that provided boot image. And then finally, if specified, it ejects and discards that image on the next system reset, making it a one-time boot to that image. And then in our task service, we set up a task that monitors this flow from end to end. And so here's an example of it. So a post to Redfish V1 Systems 1 boot image push URI of the image, as shown here, is what triggers this entire process. And so you see the binary data down at the bottom, comprising the file myimage.iso. So in this case, a CD-based image.
This also has the optional parameters. In this case, the user wants to request the service to validate the checksum to make sure it's nothing was damaged in the transmission.
Yes, and specifying SHA-256 as the checksum algorithm here, shown in the middle. Thanks, Mike. Next up, we've added a new query parameter called client context, and this allows the client to retrieve only new members added to a resource since the last time this same client accessed that collection. And this is really intended for use in our log entry collections. So read the log and then give me information from the log, everything that I haven't already seen. So make sure that I don't read the same entries over and over again. And so the way that this is implemented is that clients provide an opaque key to the service. And then under the hood, the service creates and ties a progress record to that key. And then the client on its part makes sure that it uses that same key in every subsequent request in order to advance the progress record, basically a pointer to the last record I've seen, in order to make sure that I only retrieve the newer members. And so this acts very similar to the paging mechanism that we have, except it's more client controlled. And so here's an example of it. So we do a get to the log service, and you see at the end that the client context is set to log monitor, and it's asking for the top 10 records. And the service then provides those records 1 through 10. If I then do a get to exactly these, to the same URI, again setting client context equals log monitor, the service remembers that I've already set up this context with log monitor. And so instead of starting over from the beginning, it then gives me entries 11 through 20. So as usual, our Redfish publications repository contains an official read-only copy of the Redfish schemas in our public GitHub repo, as well as all of the standard message registries, and it's at that URI. And this is really important because it creates a public durable location that can be used to reference schema or registry items, either in issue reports or forum postings or in any other sort of online reference. And it also allows developers to automatically synchronize with the Redfish releases as they come out using standard GitHub tools and processes. As usual, we update this repository each time a Redfish release becomes public. So the 2026.1 release has already been updated into that repository. And it contains all of the materials that are also published as DSP 8010 and DSP 8011. So in particular, the CSDL folder contains all of our Redfish schemas in the OData CSDL XML format. There's a /JSON schema folder that contains all of our Redfish schemas translated to JSON schema. There's an OpenAPI folder that contains our schemas in OpenAPI YAML format. There is a dictionaries folder that contains all of the schemas translated into RDE dictionaries for use by embedded devices. And then there's a /registries folder that contains all of our standardized message registries. So on the topic of conformance testing tools, we have several available. So the DMTF Redfish Forum provides a number of open source tools that can be used by service developers to validate their conformance with the Redfish protocol, with the data model, and with profiles. So in particular, the Redfish protocol validator can be used to test a live service for how well it matches up to the Redfish protocol. And this includes testing of response headers and status codes, and it's at that URI. The Redfish service validator, on the other hand, tests a live service for conformance with the schemas. So whereas the protocol validator tests the protocol, this tests the data under the protocol. And it makes sure that the JSON payloads that come back validate against the current standard model. And in general, we recommend that this is the starting point for developers, because what we've seen is that errors in the payload are much more likely to cause issues for end users and interoperability. Generally, things that show up at the protocol validator, by the time you get to this point, are relatively minor, whereas data issues are much more important. Finally, we have our Redfish interop validator, which lets you test a service against a particular interop profile. So if you have one from a interop profile from a customer or from a standards organization that you want to test against, this is a built-in way to do it, just going to this URI. And so with that, we will be shifting to our Q&A section.
All right. I don't see any questions in the chat. We do have one question that came in through email. So how is it relevant for immersion cooling of a high-powered DC, like 800 volts DC. So, whether it's immersion cooling, air cooling, or liquid cooling, high power, low power, Redfish is being adopted on a broad spectrum of infrastructure equipment. So, when you think about your power shells, your PDUs, your liquid cooling solutions, they all have management controllers. They all can provide the ability to expose a Redfish interface. What that allows a user to do is they can remotely query the status, health of their equipment, regardless of what it is. And so Redfish provides all the main infrastructure pieces for accomplishing that across any type of device. And so if you want to have your entire data center infrastructure unified for receiving Redfish alerts or querying status, doing all the lifecycle operations like deploying new firmware updates. That's where Redfish becomes relevant in those solutions. Any other questions? All right.
If not, then we will end the recorded portion of this.
Yeah. So if you want to get involved, we have our main page on the DMTF site. We have our developer portal at redfish.dmtf.org. We have our public-facing forum at redfishforum.com. We have the DMTF feedback portal, or better yet, you could join the DMTF. All right. Thank you, everyone. We'll end the recording here.